Hi, welcome. This is our first video on EzRover, and it's a quick introduction on the major elements of the web UI that is hosted by the actual EzRover, and a little bit on just driving the EzRover in its simplest format. So this is the screen. And this is actually a web UI that's actually served by the rover itself. So the rover is based on an ESP32 cam, which has Wi-Fi capability, and so a lot of the code in the rover is actually in the web browser. So you can modify it and extend it in JavaScript, and that's sort of one of the core attributes of this particular rover. One of the first things you can do is you can stream video from the rover. And if you've compiled any of the ESP32 cam demo programs, then you probably will recognize the camera control section up here, because it's borrowed from those demos. And this is the detailed configuration for the camera that you can change a lot of different things here. The one that you're probably most likely going to want to change is resolution. By default, it'll be 640/480, and it looks pretty good in this resolution, but it does require a lot of bandwidth to deliver that video from the rover to the web UI. So when you're driving around, you may want something of lower resolution. 320 by 240 is a good compromise, and if you really want to minimize bandwidth, then 160 by 120 is a good resolution. It's about 1/8 of the, or maybe 1/16 of the bandwidth of 640 by 480. We'll show it at 320 by 200 as a good compromise, and you can see it's this hamburger menu that shows that and hides it. And you can get a single frame by just clicking that. And right now the rover is actually pointing at a open window, so it's not a very good looking video. But so and then you could start the stream, and you can see my hand gets in the way, and yeah. So it's a beautiful video. Please share, and let's stop the stream. So when you're driving the rover, if you want to drive it in remote telemetry, then you're going to want to turn on video. The next section is the rover digital telemetry, and we'll get into that in just a second. But the two big things are, it will show you the speed of each wheel and how that speed changes over time. That's what this tab does. And then the pose tab will show you the position of the rover and how it changes over time. It estimates where it is and what direction it's pointing. The next section here is rover control, and all of these tabs have to do with controlling the rover and moving it. So we're going to get a little demo of turtle mode, but I just wanted to talk a little bit about that. Tank and joystick modes are both gamepad modes. So if you hook up a gamepad to the computer or mobile device that's where you're looking at the web UI, then you can control the rover with a gamepad. Tank mode is just treating the wheels like tank treads, so you can control the velocity, the speed of the left and the right wheel separately with joysticks, and make it turn or go forward or go backward that way. Joystick is just a more traditional mode where one of the joysticks is used to control throttle, thrust, and the other is used to control whether it goes left or right. It's a little bit more natural way to drive it. And go-to goal is a higher level way of commanding the rover to tell it to go to an XY position. I've got mine calibrated in centimeters, so you would put an XY position in centimeters and then say start, and the rover will just drive there and stop when it gets there. That is if everything is calibrated well, and that's the next section, rover calibration. Rover calibration is where we measure some fundamental metrics of the motors and the rover itself, and we'll have a separate video for that. And you really need to have a well-calibrated rover for go-to-goal to actually work correctly. For now, I want to actually use turtle mode, which is named that way because logo turtle graphics work in this way, where you can go forward, you can go reverse, you can spin left, you can spin right, and that's what these controls do. And they're pretty easy to use from if you're controlling your rover using the web browser on your phone. This is the sort of easiest way to control it. It's also you'll be doing a lot of testing, and this is the easiest way to test it. So first thing to think about is, what does this speed thing mean? And so and the rover is controlled by sending it a digital square wave called a pulse width modulation square wave. And that square wave has a length, and that determines how much power the motor will actually see, and therefore how much it will spin. And if you go all the way to 1, that's full power. And if you go down to 0, that's 0 power, so it's absolutely stopped. But what it turns out is that these motors and will only turn when they get enough power to turn. And so some of these values will actually the motor will just stall. It won't move anywhere. And because it doesn't have quite enough power to move. And that's particularly true when you've got right now I have the rover suspended in a box, so the wheels aren't touching the ground. And so they'll turn a little bit easier than if I were to put it on a thick piled rug. Then there's more friction to the wheels, and it will actually take more power to turn them. So the amount of power that it takes to turn the wheel sort of depends on a lot of real world physical factors. But the point here being is that the motor sometimes won't, if you got to give it enough power to turn. Prior to actually doing calibration, this speed control means percentage of maximum PWM value. And the maximum PWM value is 255. And so if we were to go to 0.5, and we can use these to be more precise, that's like 127, 128 is what the PWM value will be to the motor. And when you're, so let's try, like when you first start up, you're at 0.9. So let's try moving the motor forward, and I ask you to look up here at rover telemetry as we do this. So we're going to have the rover go forward, and we're getting telemetry now. We can see it looks like one motor is going faster than the other motor. Even though we're giving them both the exact same PWM, one's going faster than the other. And we can actually see that in the pose, because the rover is actually driving in a circle. Because it's a differential drive robot, the way you turn such a robot is you have one wheel drive faster than the other. And so one wheel will turn that arc faster, and it will result in a circle. And that's what's happening now, even though we're actually giving the rover the exact same PWM values. That's because these motors are pretty inexpensive motors, and there's a lot of variability in them. So they don't respond to the same PWM value in the same way. Now, you might get lucky, and you might get a couple of motors that are pretty closely aligned in that way, but that's the exception and not the rule. You almost always have motors that are a little bit off. And so you need to do something. If you want to drive in a straight line, the motors need to go at the same speed, and therefore you need to do some software work to make sure that you give the right PWM value to the left motor and the correct PWM value to the right motor, so they drive at the exact same speed, then the rover can go forward. And that's what's called speed control. And in the next video, we'll talk about calibrating the rover. We'll talk about calibrating the rover such that we can give it, when we give it a speed, both of the motors will drive at that same speed. And so thanks for watching this video. Hope you liked it. And the next one will be on speed control. Thanks.